Hi, everyone. My name is Lars Rönnbäck. I work at a small consultant company in Stockholm, Sweden. It's called Up to Change. And today I will be talking about something called model-driven organizations. And if we think about what the presentations we've seen today, it's been about these modeling exercises in which we actually try to capture what the business is doing in essence. And such models provide and describe a business in a very concise way. And with the model-driven organizations, we're going to be looking a little bit at where these models can take us in the long run. So it's sort of where do we go from here, given that we have these unified models that describe a whole business. And this is based on ideas from me and Christian as well. We were working on this back in 2019, and there was an article also entitled something along the lines of Towards the Model-Driven Organization in the Cutter magazine in January 2020. The buzzword at the time was data centricity. There was even a data-centric manifesto that you could sign, sort of like the Agile manifesto. But in order to understand what the model-driven organization is, we're going to start by looking at some more traditional organizations. And this is an organizational chart. And I'm sure you recognize the different parts of an organizational chart like this. The BOSS on the left side is like business operational system support. And you have some data engineers there. This is one of those fortunate companies that have their own research and development department. And the data scientists are on the right-hand side underneath that. So let's introduce some systems that you usually find in businesses like this. So you have an HR system, an ERP system, and a CRM system. And of course, people use these systems and produce data thanks to them using these systems in different ways. And we cannot forget the customers either. They are also producing data that somehow end up in these systems. And traditionally, what we have been doing is to build data warehouses. And this is where the modeling exercises come into place as well. So each of these systems have their own databases, and we extract and integrate data when it goes into the data warehouse. And you're all familiar with this, I suppose. Once the data is in this unified model within the data warehouse, data scientists start to work with this data and perform some sort of analysis. And that results in some sort of insights. And those insights are fed back to the various managers that you find within those departments. And those departments normally have some sort of report that they provide to the top management, and perhaps quarterly, and preferably with some sort of action plans if something, well, depending on what they see in the data. So this is what many data-driven businesses look like today. And there are some pain points. I'm sure you've heard some of these before. One is that if you have a quarterly action plan, that could be too slow to react, because these days you have to really adapt fast to things that are happening in the market. So if you discover something in the data, it could be too long to wait an entire quarter before you actually get some one in the top level management to approve these actions that you should take. And of course, one other thing is congestion among the data engineers that maintain these data warehouses. So I wouldn't say that it's always the fault of the data engineers. It could also be that they don't have the proper method or technology in their data warehouse. I've seen many successful data warehouses where you actually can adapt quickly to change, but I've also seen many more that look more or less like just a bunch of tables thrown together, and there's quite a lot of work when you need to adapt to changes. So because of this congestion issue and management feeling that everything is taking too long when they want a new report or anything, or when there's new data coming in, or they want to enrich the data with external data, stuff like that, they find other solutions, and in the end, the data warehouse gets a bad reputation within the business. And then the common conception then is, right now anyway, or has been for a little while, that centralization is actually the problem here. And that has spun off a wave of thinking more along the lines of decentralization. So let us look at a different approach. So here we have the same organizational chart, but instead of having the data engineers within IT there, we're going to move them out into the different departments to put them closer to the business. Then we have the systems. We have an HR system, an ERP system, the CRM system, just as before. But instead of building a data warehouse, we're going to build something called data products. And this is the foundation for what is called a data mesh. And here we still have the management or people working within the different departments producing data. Customers produce data, go into these systems. The systems have their databases. We extract data. But instead of having to do this integration step, we can extract straight into a data product that is specific for each system. And of course, these data products must have some sort of database of their own. And the data scientists can now do analysis using these data products instead of a data warehouse. They produce insights. Insights go to the management, and at best, you could improve the rate with which you produce these reports to the top level management. So now you're down to, say, monthly or maybe even weekly action plans that can be put into effect. So are there any pain points with this approach? Well, let's look at the good stuff first. The benefits is that you get a faster response time, and by putting the data engineers closer to the business, you get a better cooperation between the business and IT. You also get a higher adaptation rate when it comes to changes that are happening, because you reduce the scope. So changes that happen within the HR system only affect the HR system data product, for example. So this is really good, right? Well, it doesn't come without its own pain points. So the problem here is that you don't really do the integration when you put the data into the data products. So you have to do some sort of integration on the fly when you want to do the analysis. And that, of course, could be quite difficult to do. At least for us who have been working with data warehouses know how tricky integration can be. You also get more maintenance objects. Now you have maybe several data products, each being their own maintenance object that you have to maintain and have a owner for, etc., etc. And of course, we run a risk here of ending up with silos where each of these departments with their own data products become their own silo, and those monthly action plans are actually just from the perspective of that department. So you lose the big picture here. Okay, so what do we do? I think there are some good things about both of these approaches. But if we look at the data mesh, we can see that in that we're probably going to see people who will state that decentralization is the problem. And I believe we're moving in waves where we're moving from centralization to decentralization to centralization to decentralization again. So in this case, I think the decentralization wave that we're in with the data mesh will probably end with another centralization wave. But this time I think it will be different. And now we're getting into this model-driven organization and the idea. So let's start at the bottom now instead of this organizational chart. We have the data modelers, we have the data scientists. We have a unified model of the business, and it contains core business concepts like employee, budget, purchase, customer. Then we have the same structure as before, but not exactly. If you look at this, instead of having the traditional departments that we have in an organization, we're now going to organize around the core business concepts instead. So we have an employee department, a budget department, a purchase department, and a customer department. So of course this unified model lives in some sort of database. We implement it in what I call a unified database. And in this database, you have this model and you have a lot of data. And on top of that, we build a new type of application that are thinner than the traditional applications in the sense that these applications will not have their own databases. Instead, they will work directly on this unified database. And it will use simple CRUD operations, create, read, update, delete. So it has a simple interface when interacting with this unified database. And somehow you need to have some sort of data contracts here that define how you're going to talk to this unified database. So instead of having those data product developers that are close to the business, we are going to relabel them as contract engineers, and they will still be working close to the business. The business produce data the way they did before. Data scientists can now do analysis again, but it's doing it against a unified model, so it's already integrated from the start. They produce insights, but instead of shipping the insights to the different managers, they're going to write back those insights into the unified database. So we actually store whatever they find out there as well. And reports that go both to intermediate managers and the top level management can also be run directly against this unified database, which means reports can be live against this data. And it's sort of, instead of having a push of information towards the top level management is more working on a pull basis, where they actually pull out the necessary information that they need whenever they need it. And what are the benefits of working like this? Well, you have zero integration if you look down at the bottom, because data in this unified database is already integrated from the start, because you're starting out with the unified model as a base for everything that goes on in the organization. And it provides a very nice marriage of business and IT. You get even faster response times at the top level management, and it keeps the big picture intact. And you still have this reduced scope thanks to the different departments working with their contract engineers when it comes to how programs and so are going to interact with the database. And of course, these thin apps, they don't exist yet. So at least to begin with, I believe that these are not going to be available off the shelf. So you probably need some sort of application development team in-house. And the downside of this, of course, is that it relies on a lot of new technology and thinking. So why do we think that this is something that is going to happen? Well, the reason is that we're seeing quite a lot of things in the market right now that points towards this becoming a reality. I believe that data warehousing is, unfortunately, in a sense, a little bit burnt. I hear a lot of businesses talk about data warehousing with negative connotations and a line they do not want to walk down again. And this application-centric mindset that we have today, when it comes to the application landscape in a business, that really only benefits the vendors, because they are able to lock in data within their applications that the business actually really owns, but often have a really hard time getting out of those applications when they want to, for example, migrate to a different vendor. And we are seeing some runaway costs and failed initiatives today when it comes to data warehouses. But I believe we will see that with the data mesh as well, and also with master data. And there are technological advancements. Snowflake has something called the Unistore, and this is something that will be launching soon, in which you can have a single database that supports both OLAP and OLTP workloads. So you can do both analytical and transactional processing in the same database. Along with this, we have the Snowflake Marketplace, where they will open up for something called native applications, and those applications will be sold on this marketplace. And you can see that these are probably going to be those types of thin applications that you can run on top of a unified model. Snowflake is not the only one. We have also Microsoft with their Dataverse, and possibly also now with Microsoft Fabric. And we also, at least right now, are in a situation where there's an economical squeeze. Businesses will not have as much money right now to spend on applications or exotic data solutions. So they will probably need something in the future that is more efficient than the structure that they have today. And we also have this socio-technological aspect that we're borrowing from the data mesh, where we want to reduce the divide between the IT and the business, and we can maintain that with a model-driven organization. If you also look at the way data is stored today in different applications and also in the data mesh in the products, there's a risk of those being or becoming black boxes. And as businesses become more regulated, such black boxes will probably not be tolerated in the future. And for those of you who are aware of master data management, we already have something similar to these unified models today in those types of systems, but they are not taking like a holistic approach. So if you were to take a master data management system and make it holistic and say that all the important business data is master data, you would sort of get a grandmaster data management system. And this unified model and model-driven organization is quite similar to what you would get if you had that. And we also have some businesses out there that are actually working a lot like this already, even if they haven't really classified themselves as model-driven organizations. Okay, so finally, I'd just like to add a slide when it comes to very recent developments. Of course, if you look at that layer we had in there where you had those thin applications, it's quite thinkable that in the future you could replace that with some sort of large language model instead. Because the operations that you do against the database are quite simple and well defined thanks to these contracts. So a properly trained large language model could actually understand the contracts and produce the necessary CRUD operations, create, read, update, delete against the database based on natural language interfaces. And of course, it could probably also do the analysis at that point in time as well.
One minute left.
Yep. And with that, I'd like to thank you, everyone, for listening to this. And I'll end with this poem by Bing.